Okay, draw 1,3,5 trimethyl cyclohexane using a hexagon to represent the ring. Okay, so let's draw a hexagon and we'll number the carbons. 1, 2, 3, 4, 5, 6. So 1,3,5 trimethyl. And we'll just put 1, 3, and 5 there. Now, how many cis-trans isomers are possible? Well, let's just make them all cis. So they're all cis. And if you, let's draw this again and make, let's say, this one coming out at you, and let's just make this one going back and that one going back. Okay, now this is where it gets a little bit tricky, because you might think, well, what about the other one? Why don't we make, let's just say, this one going up and this one going up and this one going back. What about that one compared to these two? Well, it's kind of tricky, but it turns out that these two are identical. So these two are identical. They're identical compounds because you can flip this ring over. So if we flip this ring over, let's just do that. So I'm going to take an imaginary line here, and we're going to flip about this line. What do we get? Well, let's do it. If you flip about that line, this one will be going back, and this one will be coming out, and this one will be coming out. So in other words, if I keep my numbering from before, this is 1, 2, 3, 4, 5, 6. Well, if I keep my numbering from before, then when I flip it, I'll be looking at this numbering: 1, 6, 5, 4, 3, 2. So we flip the 6 carbon over and over here where the 2 carbon is, and we flip the 2 carbon over to where the 6 carbon is. And same with 3 and 5. And when we flip it, these methyls that were going back are now sticking out because we flipped it 180 degrees. Okay, so now if you take this and compare it to this one, so let's compare this structure to this structure. Well, all we have to do here is rotate this in that direction in the same plane. So if we rotate this, I don't know, it's about 120 degrees, I think. If we rotate this molecule 120 degrees in the same plane, we arrive at this one. So these two compounds are, this compound and this one, these two are identical. Now, we could do the same thing. We could start with, I don't know, any one of these and just make, let's make this one coming out, but this one going back, and this one coming out or going back. Let's just have it coming out. Again, it's the same thing. We could just rotate this one and we'll arrive at this, which is identical to this. Rotating and flipping will make all of these, any one that has a single, any two are cis to each other and the other one is trans to the other two, the other methyl being trans to the first two methyls. They are all identical. So you have this one and this one, which is the same as that, and the same as that, and the same as that. There are only 2 stereoisomers. So only 2 stereoisomers of 1,3,5 trimethyl cyclohexane. pretty tricky.